Hello, everyone. My name is David Evers. I'm the Executive Director and Chief Scientist for Biodiversity Research Institute, and I'm also the co-lead for the Fate and Transport Global Mercury Partnership. And today, I'm happy to have this presentation for all of you on the guidance on monitoring to support the effectiveness evaluation. And the way we are intending this to play out today is we have 5 speakers. They'll each have around 10 minutes. The idea is if there's 1 or 2 questions, and if we're on time, please put your questions in the chat box. Everybody can see them that way, and I'll try to attend to those questions. And then if there's time at the end, hopefully there is, we can open up the floor and also go through any sort of final questions at that time. So because we have a full slate of presenters, I'd like to hand this off to Manuela Miranda, and she will actually present more of the process and the background of this Mercury monitoring guidance document that the 5 of us have really spent the past year working on. Manuela?
Okay, I think I'm unmuted now. Good morning, good evening, everyone. It's a big pleasure to be here at this event that marks the closing to the end, that we are nearing the end of a long process that was the development of the guidance on monitoring and of mercury and mercury compounds to support the evaluation of the effectiveness of the Minamata Convention. I'd like to thank BRI and specifically David, Deborah, and Mark for the effort that they've put in putting this together, and also my colleagues at the Secretariat. Let me have the next slide, please, Mark. As you know, the convention, the Minamata Convention, has a product cycle approach where mercury is dealt with in different articles, starting from the origins of mercury in mining to waste, going through trade, supply, demand, use in products, and so on. The convention also has a number of enabling articles which support the implementation of the other substantive articles. One of these articles is Article 22 that calls for the effectiveness evaluation of the convention, in which the COP shall periodically evaluate the effectiveness of the convention on the basis of available scientific, environmental, technical, financial, and economic information. So monitoring has a very important role in monitoring the effectiveness of the convention at the global scale. And this was further supported by many decisions since COP 1, 2, and 3. And there is one decision in particular that gives the Secretariat, the mandate to advance work on the development of the guidance on monitoring to maintain harmonized, comparable information on mercury levels in the environment. Here, I should also mention that monitoring is not the only channel that will flow into the effectiveness evaluation of the convention, but there is also reports. There are other reports. There's national reports that are very important. There is a report on trade, supply, and demand that's gonna be developed in the coming years, in the next intersessional period. There are the indicators that are extremely important, and there are a number of other information coming from different sources. If I could have the next slide, please. A little bit about the process. David already mentioned that this was the guidance was developed over the last year. I think it was even closer to the last year and a half. It was set out as a very iterative and participatory process from the get-go. And the idea was to provide scientific and technical guidance to support the COP to obtain comparable monitoring data. The process started with a roadmap that was developed by the Secretariat in consultation with the Bureau. The Bureau had some input, there was an updated roadmap, and then an annotated outline was developed. And in parallel, parties and organizations nominated experts to support the process. This was a crucial point. We have more than 100 experts that are participating in this process. Thereafter, the Secretariat engaged consultants who are here today. They are the chapter authors. They are the brain behind trying to get all this different information coming from the different experts and trying to synthesize that in a way that it's comprehensive, but at the same time accessible. So there was this drafting done by the consultants and the Secretariat. And we had several online meetings with the nominated experts. Again, these are experts that were nominated by parties and organizations, and they had a crucial role in this process. There were several online meetings until the Secretariat released the first draft of the guidance, and that went for commenting by parties and organizations. We had a second round of drafting based on the comments, online meetings, and then a second draft was released. The resulting documents are shown on the screen. We have document 18, addendum 2, which is the executive summary of the guidance. It's really a policy level. It's a document. And then we have the technical guidance that's in provided in information document 12. And there is also supplementary information that has not been published yet. We expect to publish it between COP 4.1 and 4.2, hopefully still this year. And this contains, I will show you a little bit in the next slide, please, the content of the guidance. The guidance itself also has an executive summary. Of course, it's the same as in document 18 addendum 2. And it has 3 chapters on different matrices, atmospheric, Mercury, Biota, and Human Biomonitoring, and 1 chapter that puts it all together through a cross-media data analysis. The supplementary material is divided in 2 parts. It has an overview of ongoing monitoring programs and provides links to their SOPs, to their standard operating procedures. So this is very technical. These are laboratory and field methods. And has a part B that has considerations on quality assurance and quality control procedures for laboratory analysis as well as field sampling, and a draft template that will be tested. And this is for the submission of information to support the effectiveness evaluation. It's an initial template that we hope will be improved as it's used. Next slide, please. So going into the content itself of the guidance, in chapter 1 is it shows the objectives of the guidance. And as you can see on the screen, there are 2 main objectives. One is to explain the role of monitoring in the effectiveness evaluation. In other words, it sets what monitoring can do, but also what it cannot do in terms to support the effectiveness evaluation. And another very important aspect is that it provides guidance to parties and to organizations on how to contribute to the effectiveness evaluation. That might be parties that are just starting their monitoring programs or have aspirations to start monitoring of Mercury, or parties and organizations that would like to expand their existing programs. Next slide, please. And before I go into chapter 2, I should also mention that the objective of the guidance is not to provide guidance to the COP on how things should be done, in the sense of it's not a prescriptive, it's a very technical guidance. It doesn't say who should do what. It's really on the technical level as opposed to a policy level. On how to implement the guidance at national level is, of course, up to each country. It's a voluntary guidance. There is no obligation even to support of individual countries to support the effectiveness evaluation. But the idea is to gather as much as voluntary information provided by countries to support the effectiveness evaluation. So the guidance does not go beyond the technical and scientific guidelines. Then there is another chapter, which is chapter 2, that sets the stage. And there are a few very important things in this chapter. One of them is the monitoring goals or objectives and the guiding questions. These help programs to provide, by answering those questions, the intention is that the data may already be somewhat comparable. And there are six, excuse me, monitoring goals. These are the estimation of contemporary mercury concentrations, both in background sites, which are not directly affected by mercury releases and emissions, as well as sites that are affected, identification of temporal trends. And this is important to be able to use existing data already so that we can look back in time and see how mercury concentrations in the environment and in humans have evolved to where we are today, and also to move forward. It has a characterization of spatial patterns, as well as an estimation of source attribution. Source attribution is extremely important to be able to distinguish what's anthropogenic sources from those that are natural sources, as well as from legacy and contemporary mercury emissions and releases. It also has two other goals, which are more of a at least at this time, of a wish list, which is the estimation of exposure and adverse impacts. At the global level, this is to the moment not yet possible, but we hope that with time, this will be supported also through efforts by the parties and the organizations, and quantification of key environmental processes. So before I move on to the next speaker, Lin-Will, I would like to thank you all for participating. I can take some questions if time allows or afterwards. And I would like to thank you all for joining here today. And a special thanks to the chapter authors. Without them, this would not have been possible. Thank you.
Thank you, Manuela. Thank you for setting the stage and walking through that process. I don't see any questions or hands. Oh, there's one more slide that it'd be very helpful for you to
I
review.
totally forgot. Yes, David, I'm sorry. I totally forgot because I cannot see what comes next. I'm sorry. I forgot the most important slide. It's usually like that, isn't it? One of the key things of the guidance is that it sets the process in 3 tiers. The first tier, it's really the most basic level of monitoring, and it requires less resources, it's cost effective and very practical and feasible. It allows really countries who want to step into monitoring. That would be the entry level. But it's nevertheless very important information. When pulled together individually, it may not be so important, but that's information when it's pulled together from different sources, if comparable, will be very useful to the effectiveness evaluation. Tier 2 is perhaps where most of the information can be directly relevant to the effectiveness evaluation. The methods are more expensive and complex, so it's not something that every country can really participate. But it helps us at assessing attribution at local, national, and global scales. Tier 3 is more of research in future directions. It helps understanding key processes that link sources to environmental concentration and exposures. So I hope that this was more clear now, and back to you, David.
Okay, excellent, excellent. And for everyone, the tier sort of approach is a pretty important part of all of this, and you'll see that integrated and woven through the rest of the presentation. So we're very fortunate to have our next speaker, Lin-Will Martin from the South African Weather Service. Lin-Will has a great expertise in atmospheric mercury monitoring and oversaw this chapter. Lin-Will.
Okay, thanks, Dave. Good morning, good evening, good afternoon, everybody. Greetings from Cape Town, South Africa. So I will just give a quick overview regarding the atmosphere chapter, which I was responsible for. Next slide, please. So the basic idea behind this chapter for the air monitoring was basically just to provide a status quo of atmospheric monitoring, what has been happening. There's been a lot of publications over the past several years concerning atmospheric mercury. So this is a well-established field when it regards to data and as well as to groups that are skilled that can do this. In terms of the guidance, the key aspects out of this chapter, I've summarized it in the following 4 points in terms of sampling and measurement method. What's another important aspect in the chapter is the section regarding site selection, also the QA, QC procedure, especially for field sampling, and then at the end of the day, the data management, what will happen with the data that is measured, the quality of it, what will happen to it, and also what further research or extractions can be done on this data. So this was the sort of the framework which I use on a possible way of how atmospheric monitoring can be conducted for parties now. Next slide, please. So just a quick summary for those who are not a bit familiar with this. Everybody knows that from Article 1 from the convention, that one of the main important things is to protect human health. I think that is the basis on where this convention is based on. And as the convention started, I think it was 2017 with the first COP meeting, there was an expert group that was appointed by the COP. And one of the reports which they were responsible for, they highlighted that air is a suitable matrix to help evaluate the convention's effectiveness. So this work on this chapter basically builds on the report of the expert group. And then just again, mercury is a natural occurring element. And especially in the atmosphere, we basically have 3 forms. And this is also the 3 forms which is discussed in this chapter. You have the gaseous elemental mercury, which is the most abundant form of mercury. And then you also have gaseous oxidized mercury and particularly bound mercury. So in the chapter, all of these aspects are discussed. Next slide. If we look at the current status, and I would just like to add that this graph is a bit outdated. This is not all the networks or all the work that is being done. This is taken from the Global Mercury Assessment of 2019, but this just gives an indication of where mercury monitoring is occurring currently. Some of the sites which is indicated on this graph is not active anymore, so this is not an up-to-date graph, but just to give an idea of where mercury monitoring is happening or has happened, and also just to see where all the gaps are and countries where we need to work on to see if mercury monitoring can be established in those parts of the world. Next slide. I want to thank Sandy Stefan for this slide. So this is a more realistic picture of what is currently happening in terms of active air sampling. And as you can see, we have large data gaps in the southern hemisphere, certain parts of the northern hemisphere. There's also big gaps. And then you have certain countries that has got more than one sampling site. But the overall idea behind this slide is just to give an indication of the big gaps in terms of monitoring that is still out there. Next slide. So if we take that picture and we look at what at the status of the convention is now, so we have about 130 parties that has ratified the Minamata Convention. And if you look at what is currently happening now, we have fewer than 15% of these countries or parties that have any sort of air monitoring program that is currently active. So we sit with a situation where about 85% of the parties to the Minamata Convention has no real air monitoring program. So the guidance then need to cater for all of the different parties because the needs of each of the parties are different. So the guidance looks at the following. It looks at parties with no monitoring activities. It provide guidance on what they can do. Then we have parties that did one method of sampling, example for wet deposition sampling, and this is very common in the APMMN network, the Asia Pacific Mercury Monitoring Network, where this is currently happening. And then you have parties that use two or more of the monitoring aid techniques. And then you have parties that is well established. They've got several monitoring stations within the country. So as Manuela has explained, to cater for all the parties, and because the needs are different, the tiered approach is the best way forward to meet all the parties' needs. And I will just quickly elaborate a bit on the tiered approach. Next slide. So basically the objective of tier 1 monitoring is to estimate the background and impacted levels and identify temporal trends, and also the trends in spatial distribution in air and in wet deposition over broad geographic areas, and provide information to inform atmospheric monitoring. The key thing for tier 1 monitoring, that it should be cost effective, practical, feasible, and sustainable. And in the guidance, we also elaborate on certain methods that could fall under tier 1 in terms of your automated instrumentation to the air monitoring. Then we have your manual, your passive, and your wet deposition manual. And the three methods which I've highlighted there is basically, in my view, for parties that has got no experience or no Mercury monitoring program currently, one of those three methods is one of the best way to start as the tier 1 monitoring. Next slide. Then tier 2 includes source attribution, characterization of spatial patterns, and estimation on exposure of humans and wildlife. So tier 2 sampling is a bit more intensive than tier 1 sampling. And also this is more for sites where more sites are located within a country. Tier 2 monitoring also looks at more high frequency monitoring, where you have your automated instruments, and also advanced mercury monitoring, like your speciation monitoring. So those can be classified as tier 2 monitoring. Next slide. Then in terms of tier 3, the main understanding, or the main focus there, is to understand key processes of affecting the mercury fate and transport. Under tier 3 monitoring, it improves the representatives of measurement and understanding of key processes related to the transformation and deposition. Tier 3 monitoring also focus on new and advanced techniques and intensive research. And because it's a tier 3 monitoring, you're also looking at quite effective or quite costly and expensive equipment to give you all these highly information that is needed. Next slide. So the conclusion of chapter 3, and I've tried to summarize it in a few points, is that monitoring of atmospheric mercury has been going on for decades. But as we have seen, that not all regions are equally covered, with the biggest data gaps in the southern hemisphere. And also that the tiered approach will give parties and organizations opportunities to start, expand, or improve on their monitoring programs, that comparable data can be generated to support the effectiveness evaluation. Parties, especially those that are starting out or that will start out with monitoring, have also an opportunity of joining one of several existing monitoring programs and network. As the air monitoring has been going on for several years, there are definitely, in most of the UN regions, there are parties that form part of well-established networks. And for a party that is starting out, it will just be to the advantage if they could partner with these established networks, learn from them, and also for capacity development. Next slide. Several monitoring methods are available, and this is also highlighted within the guidance. As Manuela has said, we just presented all the different options that is available, and any of the options is free for any party to choose which of the options they would like to follow. In terms of, there's also several studies done where automated measurements has shown good compatibility versus manual and versus special sampling. So depending on the party's needs, they can decide with what type of measurements they want to start on. What is also key, that is also documented within the guidance, is that a strong quality assurance and quality control program is needed. And this can be done by drawing from existing atmospheric mercury monitoring programs and networks. So if a party is starting out, there's no need to reinvent the wheel. They can just maybe partner with an existing network within their region, and so the monitoring network can start again. And then also, what is also key is that for monitoring, a variety of sites will provide a more comprehensive picture of the levels of mercury in the atmosphere. Again, all of the parties' needs are different. The sources within each of the countries are different. So if we can have a variety of sites, it will make it easier to compare data regionally as well as the end globally. And also, it is important to identify sites that can provide insight into the changes in atmospheric levels over time, including relevant and sensitive ecosystems. So these were the main conclusions from the A chapter. I think that's the last slide. I'm not mistaken. Next slide. Okay, thank you.
Thank you very much, Linwell. That's perfect. And just because of time, I think I'll move on to the next presentation. But please do, if you have questions, just add them to the chat and send it to everyone. I'm the next speaker, and I'm going to present on Biota next. Next slide. So just a little bit of background. I always think of this as important, that there's always the questions of why look at mercury and biota. Why not just look at soil, water, and air mercury concentrations? Well, the answer is that's just very challenging to relate mercury in the abiotic compartments to biotic compartments. So there's real value in looking at biota and still looking at those sort of relationships. It's also important to know that methylmercury can biomagnify not just in aquatic environments, but in terrestrial ecosystems as well. And every trophic change is about an order of magnitude of increase. So that trophic exchange can happen very quickly. And that's one of the big problems with methylmercury and the toxicity to us and animals. So as part of the biota chapter, there's a focus on trophic level 3 and 4. Those are predatory animals, and they include, because of Article 19, fish, reptiles, birds, and mammals. And ultimately, there's great variability in the ecosystem, methylmercury levels, and the diversity of animals. And so it creates this complexity within the biota mercury monitoring effort. And so I'm going to walk through, some of that complexity and try to compartmentalize, some of the ideas and thoughts that we need to use to move forward at a global level. Next. So trophic exchange, this is just a simple infographic to look at 5 trophic levels. Next. Tertiary consumers at trophic level 4, a lot of times are what countries are interested in looking at, because that's the trophic level that can commonly be sampled and is the one that people may interact with the most from a food standpoint. Whereas trophic level 5, they're rare species, they're higher level predators, they're less abundant, and they're harder to sample for lots of reasons. But also next, secondary consumers, trophic level 3, can also be very important. And there's some objectives within the convention, such as looking at temporal trends, where secondary consumers may play a bigger role than just looking at human health. Next. So design and elements of the biota chapter, it uses, just like Linwell walked through and Manuela explained, there's a 3-tier approach. It starts with simple loss cost arrangements, and it progresses to more complex and resource intensive approaches. And for biota, there needs to be choices that need to be made about where to monitor, what to monitor, why, and how. And sometimes they may not be simple and straightforward. So I'm going to cover through this presentation the 4 elements to be considering in greater detail: monitoring sites, selection of bioindicators, tissue types, and then ancillary measurements. Next. So monitoring site considerations can be challenging. There's a lot of places that we should monitor mercury, that it all depends on the cost and ability. There's an ecosystem sensitivity component that I'll hit on the next slide. There's a range of mercury inputs across the oceans and continents that's challenging in itself. And as you saw from Linwell's map on air mercury monitoring, which has, I think, is ahead of the game for mercury monitoring around the world, there's still big gaps in the air mercury monitoring world, let alone monitoring a standardized way with Biota. And then there's considerations of where are the existing programs and where are some of these new mercury monitoring programs that countries and regions are starting to think about. But ultimately, next, a global network of existing and new regional mercury monitoring hubs, they may be stitched together and they may provide a very good approach for assessing any sort of global patterns. Next. So this ecosystem sensitivity piece that I mentioned, it's important because there may be areas that have a lot of mercury input, and there may be risk from that mercury input, but how sensitive is the ecosystem to that mercury coming into it? It could be high sensitivity, low input, and that could cause problems. It could be low sensitivity and high input, and there is not a problem, or a problem meaning that there's effects to human health and eco health. So it's important to look at sensitivity, risk from mercury inputs, and then how that can be brought together as a threat assessment. So these are the tools that we can all use to maybe help better direct where we want to monitor. It gets at that question of where. Next. And then the monitoring sites, there are a 3-tier process. Just quickly going through these tiers, just as all of our presentations will, for the metrics of measuring mercury around the world. Is tier 1 focuses on for biota and background conditions, or those areas knowingly impacted by anthropogenic sources that are nearby. So kind of can be that either or. They can be visited annually, and hopefully they can be linked to air mercury deposition and human monitoring activities. These are the simplest sort of first step into monitoring mercury through a tier 1. There's a lot here that can be understood from a tier 1 standpoint, but by stepping to a tier 2, if we could do that, spend a little bit of more money, maybe think through the design a little bit more, a tier 2 sort of standpoint can cover a wider range of landscapes. And maybe by doing that and looking at local and large scale pressures, maybe visit less frequently. You can still look at temporal trends every 2 to 5 years, that still works, but do that on a rotating basis on all the different sites within that landscape, because it's such a great diversity in how ecosystems exchange methylmercury through those systems. And then starting to incorporate ancillary parameters will be really important, how to interpret the data. Next. And finally, tier 3 is ultimately, I think, from a science standpoint, that can relate the greatest certainty to a policy standpoint. Tier 3 can be that best sort of approach, where it really does start to focus in on understanding the underlying processes. It starts to characterize not just a site, but a whole watershed or a coastal area of interest. And a really key component of this is think of a primary location for a suite of measurements. And those measurements would start at like a super site, where you have, maybe it's near a mercury deposition station or a weather station. There could be a mercury isotope determination. And around that super site, there could be satellite sites or secondary sites. Those secondary sites can look at coastal areas. Next. Coastal ocean or coral reefs. Next. Open oceans, and these can relate to human health questions, to temporal change questions. Next. And those questions can be local fisheries or commercial fisheries. So it starts to take in a more comprehensive, holistic look at a site and explains it better. And from a policy or national interest standpoint, I think this can be ultimately maybe one of the better ways of really understanding what's happening in your system. Next. So that's a really quick rundown on where to monitor. The selection of bioindicators can also be challenging. It's all dependent on your questions. The questions related to temporal trends, spatial patterns, and Mercury source types. And those questions can be also related to geography, habitat, and ultimately to national interests and whether or not there's IUCN red listed species. Some countries have rare species that they just want to include and understand if Mercury is impacting them. Next. So we can think of all the species in the world. How do they relate to us monitoring Mercury? And this is just a quick matrix of looking at how we would do that, how we would compartmentalize things. And basically, this is geographical on the left side by biome and associated water types. And then there's bioindicators for just potential environmental impact, and there's bioindicators for human health purposes. Next. And those bioindicators for human health purposes really do relate to freshwater fish and marine fish. So we can start to narrow down and drill down into what are those organisms and taxa in the world that we really want to start looking at and help to standardize how we view things. Next. Then there's tissue types. So with tissues, when we catch an animal, we select a site, we understand our bioindicators for that site. Then there's a question of what tissue type to use. And that tissue type also relates to objectives and guiding questions, also feasibility and logistics, lab capabilities, just shipping and handling of those samples it really starts to dictate what tissue types we use. Next. And again, we can have these big tables. This is in the biota chapter. And these big tables kind of start to explain its background of what our choices are, what they may mean, and what are sort of the laboratory sort of abilities that maybe we want to look at. Next. Now, a lot of times it'll relate to fish, mussel fillets, or even biopsies. Next. Or if we're looking at birds, it could be feathers. So there's some tissue types that are more universally used than others. But you can see there's there's 4 different taxa here, many different tissue types to consider. Next. Last slide, just thinking of ancillary measurements, it's so important to collect information, other information to best understand and interpret what our mercury exposure values are all about. It helps identify different pressures and drivers, helps to quantify the relationships between these drivers and predictors. And then a lot of these ancillary measurements you can collect on site and or they're publicly available data sets. So it's really important to kind of incorporate all of that if we can. So that's my last slide. Go to the next slide, please. And I'm going to continue on because I feel the pressure now of making sure we have enough time for the last 2 speakers, and then we'll take on questions at the very end. So our next speaker, I'm very happy to introduce Neil Basu from McGill University, and Neil will talk about human biomonitoring of mercury. Neil, you have the floor.
Great, thank you. So greetings everyone from Montreal, Canada. Next slide, please. So this is just a general overview of my presentation. So just a couple points on the human biomonitoring and best practices in terms of identifying a sample population, which biomarkers to select and measure, why surveys are important, and how data can be managed and analyzed to address the effectiveness evaluation policy questions, and then end with the framework. Next slide. So the convention is really driven by the fact that mercury adversely affects human health. And throughout the convention, we see multiple mentions to vulnerable groups. So we know that mercury affects adversely human health, but to do those types of studies are very, very difficult. What's more accessible and more cost-effective is an exposure assessment. So mercury is first being taken up, human populations are first being exposed to mercury. We can then document these exposures and then use this as an indicator of potential health effects down the line. It's also a well-practiced, standardized scientific method and tool, and it's one that we can use to critically flag health issues. Next slide. So in terms of doing any human biomonitoring program, just like with the Biota group, it's important to ask questions about who, why, what, where, and when. So one important question is to determine what the target population group is. So we need to realize that all human populations worldwide are likely exposed to some amount of mercury. And so there is some value in monitoring exposures in the general population, but also in vulnerable population groups. In terms of vulnerable population groups, there are two main broad categories to consider. One are groups that are early life stages, which might be susceptible to mercury because they're developing nervous and other physiological systems are sort of quite sensitive. And then another population group, a broad category of population group, are those that are exposed to higher levels of mercury. So the selection of the population group is really a question for the parties. Are they interested in studying particular vulnerable groups of interest in their country, or are their interests concerning more general populations? Next slide. So once population groups are identified, you can also start to view them in terms of exposures to different forms of mercury. So running on the bottom of the schematic is the idea that background populations worldwide are exposed to both inorganic forms of mercury and organic methylmercury forms. But that there are certain groups that are exposed to higher amounts. So in certain occupational industrial settings, there might be higher exposures to inorganic mercury. We know that many indigenous communities that rely upon fish consumption for sustenance and culture are exposed to relatively high amounts of organic methylmercury through the diet. There might be groups that are exposed to a mix of both. So for example, in some ASGM sites, there's going to be exposure to high levels of inorganic mercury, but depending on the community, there may also be exposure to high levels of organic methylmercury through fish consumption. Next slide. So once a population group has been identified, the next important question is to figure out what biological marker will be sampled and measured. So scientifically, we know that the selection of biomarkers is relatively well accepted and understood and practiced for human biomonitoring purposes. Largely, most of the attention is focused on mercury measures in hair, blood, and urine because these are the most scientifically well understood and accepted. The collection of these types of biomarkers can be relatively non-invasive. It can require minimal training and can be relatively cheap. The analysis of these biomarkers is relatively cost-effective, especially when compared to other contaminants out there. So oftentimes when we discuss human biomonitoring programs, there is a bit of resistance because of the potential costs associated with this. For mercury, we're relatively lucky because the costs are relatively low compared to, for example, looking at persistent organic pollutants. You can do a mercury biomonitoring measurement for, I would say, under $100 US, whereas the analysis of many persistent organic pollutants can be in the thousands of dollars. It's also a great way to build technical capacity and build up laboratory infrastructure in many countries. So by having biomarker data, you also get direct evidence of exposure. Depending on the biomarker and the type of measurement you take, you can get insights into the sources of mercury and the exposure routes. Biomarker measurements can be then used to assess changes in mercury exposure over time and space. And for the biomarkers listed above, there are guidelines available from certain parties and organizations which allow interpretation, and also this information can be used in risk assessment. Next slide. So which biomarker is chosen? Again, like my colleagues, it really depends upon some of the questions that drive the effectiveness evaluation. And then key approaches for human biomonitoring. There's a lot of great documentation out there with some of the resources listed here. And as I mentioned on the previous slide, that the most common ones are hair, urine, blood, and cord blood. And really their selection is dependent upon a number of factors that are articulated in the guidance document. Next slide. So when we take the commonly used biomarkers for mercury and then overlay them to the earlier chart I showed on population, we can see that some biomarkers like urine are more applicable and useful for gauging exposures to inorganic mercury, where other ones like hair and blood might be more appropriate for looking at exposures to organic methylmercury. Next slide. So then to really deepen our understanding of biomarkers and to make linkages between potential sources and exposure routes, surveys are important here. So another important thing we did in the guidance document is to provide a range of links to surveys that have been developed by different parties and organizations. which can be used to deepen understanding of routes of exposure and sources. So for example, studies that are looking at mercury in hair and blood, this information may be used to ascertain exposures to methylmercury through fish and seafood. And to really do this well, we can rely upon good survey instruments. Next slide. So this is my final slide, and this is really the framework that we used, that we presented in the guidance document to articulate how monitoring programs can be designed for using human biomonitoring data for effectiveness evaluation type questions. In the guidance document, we talked a fair bit about existing data and data expected in the future. So as we think about the data that exists at the current moment, there are a few databases at our disposal to understand what worldwide exposures might be in sort of this pre-Minamata Convention timeframe. For example, the Global Mercury Assessment pulled together a data set of close to 500,000 biomarker measurements from many parts of the world, which can be used to understand sort of what background baseline exposures are in the pre-convention time period. But moving forward, we would like to know if it's possible to purposely build out new programs that can gauge human exposures in the effectiveness evaluation timeframe. So this is largely important because when we take stock of what's known worldwide in terms of human biomonitoring and mercury exposures, there are several parts of the world in which there's relatively little data. So the guidance document that is proposed here provides information, provides SOPs, provides a strategy for all parties to be able to purposely start new biomonitoring studies that sort of follow that tiered approach. So in tier 1, we provide guidance on what it would take for parties and organizations to create new and nascent biomonitoring programs or to maybe expand a minimal one. In this one, we proposed that the focus should probably be on a vulnerable population of interest to the party and that a total mercury measurement be taken in blood, urine, or hair. And then as we move up the tiers, we sequentially and progressively add more guidance in terms of what should be measured, the depth of measurement, the number of different types of variables that are considered. In the interest of time, I won't go through this in any greater detail, but to say that the chapter has tremendous information in terms of how human biomonitoring can be done. It pulls together some of the most important resources available worldwide that are scientifically valid and have been shown to be applicable and successful in practice. And I just want to reiterate that the guidance document involved consultations with dozens and dozens of experts and representatives of some parties. It was iterative and evolved over time and ultimately supposed to be fit for purpose. So hopefully there's something for everyone. There are some countries with narrow considerations and necessities, and there are other ones that may want to have a broader understanding. So hopefully the guidance document is fit for purpose and it can be used for a range of questions. I'll stop there and pass it on to Colin.
Great, Neil. Thank you so much. That's excellent. Because we're a little bit low on time here, I'm just responding to the questions. I just realized and I responded to all panelists, so I'm responding to everyone. So while we go through the next speaker, I'll try to answer the rest of the questions here. And Colin, I want to give you all the time you can and that I can muster here. We have like another 7 minutes, but I'll hand it off to you. This is Colin Thackeray to talk about cross-media data management monitoring and analysis from Harvard University. Thanks, Colin.
Okay, thanks, Dave. And hello, everyone. You can go to the next slide, please. So today I want to highlight analysis across media and why that's important. So analysis of the monitoring data collected for each monitoring medium separately will be informative. But analysis that draws information from multiple media at once can increase the weight of evidence in working towards the monitoring objectives that Manuela laid out at the beginning. So the more high quality monitoring data that becomes available and is used, as our understanding of the processes that take mercury between release and eventual human exposure as that understanding improves, the more detailed questions that we can answer and with higher levels of confidence. And another thing I want to point out is that more than one analysis approach can be used at once and together with information from more than one medium, and that those combined to answer the same question can give a more robust answer and more confidence and reduced uncertainty. You can go to the next slide. I'll try to be brief on this slide, but in building up that scientific weight of evidence, both breadth and depth can be useful. And so the outlined monitoring tiers roughly line up with the order of the monitoring objectives going from 1 to 6 on this slide. The later objectives in the list rely on more lines of evidence, and lines of evidence can come from the primary monitoring data and their analysis, but also information from ancillary data that's collected, cross-media analyses, and a whole bunch of mechanistic and statistical models. If we think about the increasing tiers of monitoring data, where tier 1 is more simple information, but it can be gathered broadly and answer some of these first questions, objectives on its own, and it can also form the foundation for deeper analyses, which would move into tier 2, which does allow more depth, and the analyses can be more complex, and we can start doing attribution. Attribution basically meaning answering the why questions about what we observe monitoring data. And I'll talk more about that in a minute. And then when we get to tier 3, it's really meant to improve our understanding of the key processes to support tier 1 and tier 2. And so it's more in depth and specific, but it be potentially broadly beneficial because you can apply that new knowledge more broadly. And so in the interest of time, I won't go through these 6 points in any detail, but I do want to point out that even towards the end, it can be important because when we get to quantifying these key processes and increasing our understanding of mercury processes, which we can get through the kind of highest quality monitoring data, but also through experimental and computational and modeling studies that can potentially be made available for the evaluation, then the strength of the scientific weight of evidence can be improved in an iterative way, and from one evaluation cycle to the next, you get increased confidence. You can go to the next slide, please. And so from primary release to human exposure, mercury can undergo a lot of physical and chemical and biochemical changes that interact with each other over a whole range of timescales, and that's why this cross-media analysis can be important. So this figure shows a lot of these changes and connections where the arrows represent flows of mercury from one medium to another. And for different media, there's the associated timescales of response for those reservoirs. The important points I hope to highlight with this figure is that there's a large number of connections in this kind of global mercury system, and that some of these timescales are very different between media. And so in some cases, the connections between media are essentially one way. So for example, methyl mercury in water gets uptaken by plankton, which are consumed, and the mercury can bioaccumulate in the food web, or some fish is caught and consumed by humans. And this means that there's a whole chain of processes that lead to the eventual consumption and exposure. And so an effective evaluation is going to have to lean on information about all those processes. And there are other cases where there are two-way connections, like for instance, between the atmosphere and ocean, where the ocean is a source of mercury to the atmosphere and vice versa. And this means that to understand the trends and patterns in one, we need to have information about the other. But this leads to the benefit that can be gained by using models which explicitly represent the coupling between different media, since they'll give estimates which are self-consistent. It can actually reduce our uncertainty by eliminating possibilities in each medium that are contradictory to the other media. And so there's potentially a long path to humans from emission, especially when taking into account the different timescales. So it's important to be mindful to trace changes across these timescales that interact with each other. But it's simpler in some areas and more complex in others. That'll depend on location and the emission history, etc. So we can go to the last slide. And so part of the evaluation will be attribution, and the purpose of which is to answer the why of observed trends and patterns in a given location or situation. And so separating the relative magnitude of the inputs and the drivers that are potentially influenced by the convention from those that will not be a key part of evaluating convention effectiveness. And so this figure is supposed to illustrate that attribution. And so each stack of bars represents a piece of the Mercury system that might be estimated and observed to answer a guiding question. And the colored bars that make up each stack are representations of the strength of the contribution from each individual driver, colored based on whether they can, the type of driver they are and whether they can satisfy the convention or not. And so if we start on the left, let's say human exposure, that's driven by a bunch of different factors, but one of those, mercury in fish, is itself something that's monitored and has its own drivers. And as we move to the right, we see that attributing human exposure to drivers is actually an attribution study across a variety of media. And this is why simply monitoring human exposure doesn't have as much explanatory power as monitoring and analyzing more of the system alone. And so I think I'm already over time, but I'll just say that at this stage is where having multiple lines of evidence and coming at the problem from multiple directions, be that from bottom up, so process-based, knowing the drivers and how they affect the observable quantities, or top-down analysis where you observe the quantities and infer the importance of different drivers, and combining as many analyses of the same thing to build that robustness is really important, because efficiently using all the information available will give the most complete picture. So I'll stop now and thank you all for being here, and I'll give it back to Dave for the last slide.
Great. Thank you very much, Colin. It's perfect. And there is a lot of information in that last slide. I wish we could spend a few more minutes with it, actually, but everybody can see that in the chapter. So I'd like to thank everyone for attending this side event. There's more information here. We can just leave this slide up. That's perfect, Mark. For more information about the Global Mercury Partnership, there's a webpage that you can go to where this slideshow will be available through that webpage in the top there. There's also this, I should just mention, the specific international program, the SIP, has funding for Antigua and Barbuda to start a Caribbean region mercury monitoring network, and that information can be also found at that website. And then our own website has information as well as resources. So we've been trying to answer questions in the chat box. That's perfect. Thank you so much for all your questions. And I'm going to hand it off to Mary Ann, because I think, Mary Ann, you have a few final housekeeping points, but thank you to all the panelists. Mary Ann?
And also big thanks from the Secretariat to all the panelists. This was really well done, very informative. Thank you to all of you for listening in on the session and for providing your questions in the chat. We're going to keep this WebEx open just for a few minutes to ensure that we have captured all the questions in the chat. And we look forward to many more conversations on this important topic. Thank you all. Thanks to BRI for organizing.